have a standard normal distribution, which means it's bell-shaped and symmetric, yet it is not standard because the mean is not 0, the standard deviation is not 1. So instead of having z-score boundaries, we have x-score boundaries. So x, which is IQ scores, follows a normal distribution with a mean of 100 and a standard deviation of 15. Right? And we're being asked to find x. All right, so in the previous example, I did this one in another video, and we used the inverse norm function in Excel to get our answer. So we were starting with a known area and working our way out to the z-score. You could also look in the negative z table, looking for an area in the body of the table of 0.11 or the closest thing to it, and you would be able to figure out your answer that way as well. But we're going to do this now for a non-standard. Now I'm going to do this as if I'm using my z-score table, which means that I have to turn that x value into, or rather I'm going to look for an area in the table of 0.1431. Then I will find whichever z-score lines up with it, and I can see that this is to the right of the mean. So whatever the mean is, which is 100 for my x values, for my z-score scale, that would be a 0. So once I look up this area in the negative z-score table, it's going to give me the negative version over here because of the symmetry of those two tails. And then I will just change the sign of it and I will have a positive z-score. So I know that the z-score that corresponds to the x value I'm looking for is going to be positive. All right, so I will look for an area of 0.1431 in the body of my table and work my way out to the z-score. All right, so let's go over to the z-score table. Oh, let me make sure I remember which. Okay, 0.1431, that's what I'm looking for. I'm going to go over to my z table. 1431, 0.1431. So I'm looking, looks like right in here, between 0.1446 and 0.1423. So that is a z-score of negative 1.0, and then the last digit could be either 6 or 7. Right, so which one of these seems closer? Negative 1.431. So the difference, let me write these down. 0.1446 would have, so the probability of z less than I think it was negative 1.06, I think. That was 0.1446, and the probability that z was less than negative 1.07 was 0.14. Okay, let me double check my numbers here. Okay, so the 0.1446 and 23. 446 23. Okay, so that's all correct. Now the distance 0.1446 minus 0.1431, 5. This one .0008. So this is actually closer. But I'm also going to use inverse norm, or norm.inverse, in my Excel. And I'm going to put in the area of 0.1431, the mean of 100, the standard deviation of 15. And I'm also going to do it with a mean of 0 and a standard deviation of 1, so I can see if the z-score is right. So the z-score, let me just figure that one out in Excel real quick. 1.0665, which rounds off to negative 1.07. So that's what I got from Excel using mean of 0 and a standard deviation of 1. So that's a z-score. Right, so that's a z. Now the x value, I would get that by doing 115 as my mean and standard deviation. So let me do that and come right back. Alright, so the x value I found, an IQ score of 84. And it says the indicated IQ score is, and round to the nearest whole number as needed. So the answer I got from Excel looked like this, out a few decimal places. The final answer should be an IQ score, not its relative placement to its mean. Answer should be 84. 84 would be the IQ score corresponding to the negative side, but remember the original picture was on the right, so I need to change my z-score sign to a positive. So even though I got a negative here, this z-score over here on this side is going to be positive 1.07. Right, so that should give me a different answer, which is, let's see, what do I get when I do a z-score? If z is equal to x minus mu over sigma, and if I do inverse operations until I've isolated x, I get z times sigma equals x minus the mean. Then if I add the mean to both sides to get x alone, I'll have this. Alright, so I'm going to use the x formula to convert my z-score. So I'm looking for x. I'm going to find that by taking the positive z-score on the right times the standard deviation of 15 and plus the mean of 100. Let me calculate that. So that works out to an IQ score of 116.05, which rounded to the nearest integer is this. So that is the final answer, and I hope you enjoyed that lovely. That was a good problem. I like that problem. It gave me the opportunity to go over a lot of little nuances that can happen in a problem.